Okay, let's look at another quadratic equation problem. Our problem is 6x squared minus 5x minus 4 equals 0. Now, if we want to solve this using the quadratic equation, we need to pick out our a, b, and c. First, get all your terms on the left of the equals. We already have that. Get them in order, the x squared, the x, and the whole number. So when I go to pick them out, my a is going to be 6. It's whatever's in front of your x squared. My b is going to be negative 5. That's in front of my x. And my c will be the negative 4. Remember, you have to have all of those on the left of the equals before you pick them out. Now I want to plug them in the equation. My equation says negative b, so a negative 5 would be 5. Plus or minus square root of b squared is 25 minus 4 times a, which is 6, times c, which is negative 4. On the bottom, we're going to have 2 times a, which would be 2 times 6. Now on top, when we multiply that out, underneath the radical, we're going to have 5 plus or minus square root of 121, and all of that will be over 2 times 6, which is 12. To get the 121, I did 25 minus the 4 times the 6 times the negative 4. And that gave me the 121 underneath the radical. Now with this problem, it's a little bit different, because normally we would reduce the radical and then stop if we couldn't go on. Square root of 121 is 11 though. So we will have 5 plus or minus 11 over 12. Now we can't leave our answer 5 plus or minus 11 over 12. We could leave it 5 plus or minus square root of 11 over 12 if that was the case, but our square root is gone. Our radicals disappeared, square root of 121 is 11, and now we have all whole numbers. We can finish this one. We can do 5 plus 11 and get 16 over 12. We can do 5 minus 11 and get negative 6 over 12. Then you have to reduce those. 16 over 12 will reduce to 4/3, and negative 6 over 12 would reduce to a negative 1/2. Those would be my two final answers, 4/3 and a negative 1/2. Now, one of the interesting things about this one is when your square root, your radical disappears, and you don't have that left, and you don't have a radical, and you don't have any imaginary numbers, you can finish it and get two final answers. That also tells me this problem could have been factored. We did not have to use quadratic formula on it. If we had chosen to factor it, it would have worked, and we would have gotten the same two answers. If you end up with a radical or an I, those problems do not factor. They are considered prime.